Levi, thank you.
I don't know if Mondays can be happy, but I'm trying.
That's a morbid joke. Yeah, you're right. I'm trying to be positive, Levi. Come
Right.
on. Let's see. But you're right. I totally get it. And Mondays are hard for me too. Uh, they are. Maybe I'll bet you honestly probably know that though, don't you? I try to pretend like they're not, but they are. Who's all here? Xavier, Tatiana, Anaya, Brooke, Anthony, Levi, Savannah, Beniam, and Baraket. Beniam and Baraket. Awesome. Okay. You know what? You're totally right. Mondays are not easy to deal with, but I'll tell you something. I am trying to make 2022, just for me personally, like at work and at home and every aspect of my life, better on my own. And what I mean is, I'm trying to have a better attitude. I'm trying to take action on the things that have been bothering me. Um, there's like a list of things I've been wanting to do at my house, and I've been putting them off for like 8 years because it's never a good time. But I've already started that list. I've got one thing finished since Christmas, and I'm going to do some other things this year. I'm just going to do them. I'm going to stop waiting, stop, putting it off like I've been doing and do it. My point is, I'm going to try to take ownership of this ridiculous world of my own after COVID because it's never, I can't wait around for like the world to get better for me. So I'm just going to do what I can uh, for myself. So, in the spirit of that, let's try to make Monday as best as we can together. I'm excited already. So, everybody, welcome. My name is Josiah. I'm glad you're all here. You already know our class meetings are Monday through Thursday at 11 o'clock. Real quick, I want to go through some information that would normally be on a syllabus about the class. So, for you new folks and for everyone else from fall, just in case you have any questions, let's go through this real quick together. So our lessons and meetings are on Zoom. I had hoped to have class in person, but we're not going to do that now. So our lessons and meetings will always be on Zoom on this link you're already with me on. There we go. Daily assignments, our work that we'll do in class, our quizzes, unit tests, all on Admentum. However, sometimes I will be doing outside assignments outside of Admentum. Those of you who are with me in the fall, remember we did stuff on GeoGebra, we did stuff on Google Slides, and sometimes we even did questions on paper. And sometimes I do want to do that instead of a mastery test. Um, I'm looking at what they're offering in Edmentum and what is important for you to get out of out of this class that I want you to get out of the class at least. And so that's why I might be changing the assignment sometimes and giving you something outside of Edmentum. It's not to punish you. It's not to make it harder. It's to make it easier and get to the point instead of doing it on Edmentum. But we will always be doing the unit tests for sure on Edmentum. Also, a reminder, please take notes during class to the best you can of examples or definitions. I want you to use these on your assignments. I want you to have a record of what we've been doing so that way you can go back and use that again later on the test or on the daily homework or whatever it is. Um, Side note about this is if you need paper or pencils or even a calculator, I would like to get that to you. So let me know. You can write me an email. You can write me a private message if you want paper or any supplies, calculator, etc. Pencils. We got that at the school, and you can come by and get it, or I can send it to you in the mail, or whatever. We can work that out however it's best. Pencils. Another reminder to add remind.com. So, new folks, And all older folks too who still haven't added. I want to be able to let you know if I'm not going to be here. Some days I am sick or can't do class. And if you need help on an assignment, or if you have any questions about class or anything at all, you can text me. This is a texting program that I can see your guys' messages throughout the workday. So as I'm doing other things, I get messages from you and can respond right away. And that's my goal, is to not keep you waiting. And this is just the most direct way to communicate. You probably use it also with your normal teacher anyways. You've probably heard of remind.com. So please add me on Remind. And later this afternoon, I will try to add you all individually, those who haven't added. Parents are also welcome. I'd love to have parents and students on this so we can all be on the same page. And what's new this year, and this is new for all of you, I've made a Google Classroom, and I'm going to be putting the lessons, so just the PowerPoint, so you can click through it again later, the videos, and the homework assignment for those particular units on the Google Classroom. And this is something else you'll have to add or accept invitation to add the Google Classroom in your Google account, your Gmail. You all should have gotten like an invitation from me this morning or from Google Classroom saying, add this class. So look in your Gmail and add the classroom for Math 1B. That's from me this morning. That way you can go back and see the lessons later. I'm hoping this way it'll make it more organized and it'll make it less confusing if you're wondering, what are my homework assignments? What do I have to have done? What are the lessons this that goes with this, and so forth. So I'll probably still have them on YouTube, but they'll all be there organized in Google Classroom, so easier. I'll be able to do that after each lesson. So in the afternoon today, I'll put up today's information, the homework assignment, the lesson, the video, and everything. If I notice people haven't added it after tomorrow and the next day, I'm going to be calling you at home to hound you and make sure you add that. And on Remind, I'd like your parents also added so they can see what's going on too. If they have any questions, it just should just make the information easier to access. So everyone's welcome to add this.
Hi, teacher.
Hi, Robel.
I'm good.
I've got you down.
Thank you.
Thank you. So there's our new information for this year. Let's get started. It's already 11:10. Okay, so in Edmentum, if anyone's noticed this morning, I added you all to your new class, Math 1B. We're doing Unit 6. Unit 6. And the lesson for today is called Arithmetic Sequences and Series. So two different things we're looking at, arithmetic sequences and arithmetic series. So we're going to talk about what that is, how to figure out what the sequence
Teacher, can you
is.
open for the big test, Unit 5?
Sorry, Philman, what's that?
Can you open for me the Unit 5 big test?
Oh, yeah, but I'll do that after class, okay?
Okay.
I want you to take notes on this new stuff. This is Unit 6 we're starting today.
Yeah. Okay. Yeah,
Okay, but just give me a reminder. I'll open that this afternoon for sure.
Yeah. Okay.
Okay, thanks, Philman.
Thank you. Yeah.
All right, here we go. Let's look at an example to start with. Actually, let's define it first. I thought I had an example to start with. So put this down in your notes. If you don't have paper today, I want you to take a picture or a screenshot so you have this later to look at. Arithmetic sequence. It's a list of numbers whose pattern from one term to the next is a common difference. A common difference. So we've actually got another vocab word happening in this definition. A sequence is a list of numbers whose pattern from one to the next is a common difference. Make sure to write this down. I'm going to move on in just a second. If you can't write it down because you don't have paper today, take a picture. and then we'll look at an example. Here's an example to start with. It's a list of numbers. 5, 8, 11, 14, and 17. And then there's little dots at the end means it goes on further. But I'm just stopping there. We've got 5 numbers in our list. But the little dots, the ellipses, means this continues on forever. Here's the question. I'd like everyone to try answering this to the best of your ability in the chat. I want to hear from all of you. You can write the message directly to me, or you can write it to the whole group, whatever you're most comfortable with. No big deal. But at least write it to me, okay? Here's the question. Do you see a pattern in those numbers? Is there a pattern to go from 5 to 8 to 11 to 14 and up? Take a moment, see if you can find the pattern, and tell me in the chat. I want to hear from all of you. I see one chat message. Should be 11 of you, so I'm going to wait until I get your responses before we move on. What is the pattern? If you can't tell, that's okay. Just say you don't know, but tell me what you think. Let me write this down. What is the pattern? From one number to the next in this sequence. What is the rule? Is there some rule telling us how to find the next number in the list? Okay, thank you. I see 4 of you. Keep going. That means there's still 7 of you who haven't written me. I want to hear from all of you. Remember, there's not one right answer. I just want to hear you think about this and get you to express it in words to the best you can. What is the pattern? I should say I'm not looking for one right answer. You're not going to get it wrong or something if you don't say it the right way. I just want you to think about this. Is there a pattern to go from 5 to 8, 8 to 11, 11 to 14, 14 to 17?
I'm pretty sure that it goes up 3 numbers.
Nice. Does that work, Levi, for everything we see there? Check it and let me know. I still want to hear from everybody else. Let's see who wrote in the chat.
So I think I checked it right. And for every number, it does go up 3.
Levi, thank you for expressing all that. And let's see. Philmon, Savannah, Brooke, and Tatiana, and Anaya. I appreciate you guys messaging me and trying to answer that question. I think everyone who answered did get what what we can see out of this. Oh, there's one more. Who's that? Beniam. Okay, so Levi said it's going up by 3. That's the same thing that a lot of you said in the chat as well. Thank you, Brooke and Anaya, Tatiana. Levi checked it. It confirmed, yeah, it's going up by 3 to kind of go to the next number. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. Okay, awesome. Here's my next question to everybody. What's the next number on the list? What goes here after 17? Here comes some answers. Cool. 4 of you. 5. Keep them coming. What's the next number after 17? 6 of you. Awesome. I want to hear from Anthony. I want to hear from Baraket. Let's see. Savannah, did you answer? Levi?
20.
Nice. Good job, everybody. Good job, Beniam, Anaya, Savannah, Brooke, Tatiana. Awesome. Yeah. And so how you found that is finding that first rule, right? The pattern. And then we found it was +3. So then if we add 3 again, it should get us the new number, 20. This number that we found, the pattern that we found, that's the common difference. Let me add that to our notes right here. The common difference for this sequence was +3. It's not always +3, right? Not every sequence has the same common difference. It's up to us to find what the common difference is for each different problem. But great job on this first one. Okay, we're done with this page. So finish up your notes. Make sure that you have the definition of arithmetic sequence right here. And I do want you practicing those words, like the terms, like common difference. Say it out loud. You don't have to do it with your mic on, but just practice at home. No one can hear you, so it's all good. Get some practice using this language. Arithmetic sequence. I know that's a hard word. Arithmetic. It's like arithmetic, basically. Arithmetic. Later, not today, later we're going to look at a different kind of sequence that's not arithmetic. So that's why we're naming it this, because there are different types. Great job, everybody. Let's look at what's next. Okay. So here is the notation, the sequence notation. And notation is just a fancy word for how we write it. The notation. Now I have another sequence listed here. 10, 12, 14, 16, 18. In order to use the notation, in order to write the sequence, we need to find the common difference. We need to find the first term. That's the first number, the starting number. Those are actually the only ingredients we're going to need. So anytime we want to write the formula for a sequence, we need the first number in the list and we need the common difference. So before I put down the sequence formula, I'm going to add a little bit to the notes and we're going to identify those parts. So what we need, or what you need, what we all need to write the sequence as a formula, to write So what we need to write the sequence formula is the first term and we need the common difference. Now, the first term is written this way in the formula, the generic blank version of the formula. A1. The common difference, we're going to call that D for difference. Put some arrows here. So the first term in the formula is called A1. And the common difference is called D for difference. That's pretty easy, I think. And also for this example, and to learn the formula itself, copy down the sequence I have, 10, 12, 14, 16, 18. And I'm going to label those above it. So the first term is A1. The second term is A2, and so forth. A3 is the third term, the third number in the list. And so what we have there so far is just the first 5 terms. And how we notate them generically is A sub the number. A sub 1, A sub 2, A sub 3. Here's what I'm saying. A sub 1. That, for example, that's how we say that. A sub 1. Or A sub 2. Now, the list of numbers, the sequence of numbers, it goes on forever. I mentioned that earlier. So we could, as long as we find the common difference, we could find the next one in the list. Like we did before, take a minute and see if you can find for this sequence, the 10, 12, 14, what's the next number in the list? Any ideas, any suggestions? Can we tell what the next number should be here? What would be the a sub 6 term? I see a chat message. Totally. Thank you. And actually, I now realize that's the same next answer for the last one we did. Good. Thank you, Beniam and Savannah. Yeah, it's 20. And how did they find that? Common difference here is +2 this time. So we found the space between 10 and 12 is +2, +2, and that keeps working all the way up, so we can use it to find the 20. Now, instead of always having to write the entire list out, what if I just wanted to know a faraway number in the list? So how we signify some random number far down the list, far down the sequence, is n. And you're going to see this in some of our word problems. You're going to see this in the formula as well, n. So n stands for just the nth number in the list. It could be the 100th, it could be the 500th, it could be the 20th, whatever. It's just some place in the list. So how I would show that in the formula is a sub n. That means the actual number, or no, that's the place. So that's like the nth place in the sequence, where n is the actual number in the sequence. Before I show you the formula, we're going to add on a little more here. So for example, just to use some of this language, this a sub n and the n and stuff like that, I'm going to put some statements up here based on what we see so far. I'm going to make a box around that. So first statement is a sub 1 is 10. It's the first number in the list. A sub 1 means the first number, basically. A sub 3 is 14. Help me out now. I'm going to ask you to answer this in the chat. What is a sub 5? A sub 5 is what? See if you can find that from our sequence above. What is a sub 5? Tell me in the chat. Here they come. Good, good, good. I see 4 new answers. Good. A sub 5 is 18. Oops. Now, the question is, how do we know what a sub n is? And this is where things get weird. This is why the formula is useful. A sub n is going to be writing a formula to figure out any number in the list. So we don't have to write the whole thing out like 100 numbers deep or however far down we're asked to find. So to find the a sub n number, which is any number, here's our formula. I'm going to read this. I want you to write this down. Make sure to have this copied down. A sub n is equal to a sub 1 plus d times n minus 1. Now I'm going to label some of these parts. A sub n means the nth number in the sequence, in the list. A sub 1 means the first number, so that's not too bad, right? As long as we have the list, we should be able to find that pretty fast. This is the first number in the sequence. D, we talked about that. That's the common difference. So we would have to know what is the pattern to go up or down with. And then n is like the place in the list. So if we're looking for the fifth number, if we're looking for a sub of 5, we're going to plug in 5 for n. Just like how we usually plug in numbers for x, think of n as like the input and a sub n as our output. Think of n as like plugging in for x, and a sub n is y, what you get out. I want to show you an example using the same sequence we've already been using above. So I'm going to make a box here to separate some of our work. So I'm going to try using this formula with you to find some of the numbers we already know are in the list. So for instance, let's try to find A2. Now I know that you can look up at the list and you already know A2 is 12. But let's use the formula and make sure it works. Let's see how it works. So I'm going to plug in 2 in for n in the parts in the formula. We also have to plug in the first number for A1, and we have to plug in the common difference. So here's how we use our formula. A sub 2. Find A sub 2. So it's the first term, that's A1, so that's 10, plus the common difference this time is plus 2. That's what we found earlier. That's the pattern. Parentheses is n minus 1. If I'm trying to find a sub 2, then we're plugging in 2 in this example. 2 minus 1. Now, simplify inside the parentheses, multiply that to the 2 on the outside, and then we'll add 10. So always remember your PEMDAS. We have to do parentheses first, then multiplication. And then we end with adding 10. So in the parentheses, 2 minus 1 is just 1. 1 times 2 is 2. 10 plus 2 is 12. So we've confirmed a sub 2, that's the second number in the sequence, is 12. We used our formula for it. Maybe I should have chosen a farther away number. Why don't we test it out to see if it works for a sub 6? A lot of you already found that and answered in the chat. A sub 6 is 20. So let's use the formula again to confirm it works for a sub 6. I am going to move to a new screen to do this. Okay. Here's our generic formula. Means blank, nothing plugged in. And now I want to find a sub 6. Again, we've already found this by making the list, but I just want to confirm it works. Find a sub 6. So a6 is equal to a1, the first term, 10. The common difference, remember that's the same for all these. That was plus 2. And now n is changing. It's 6 because we're trying to find the sixth number in the list. So we have to do this in steps. Do the subtraction inside the parentheses. 6 minus 1 is 5. And the 2 on the outside, that's being multiplied to whatever we've got inside the parentheses. So 2 times 5 is 10. 10 plus 10 is 20. And that's good. That works out exactly what we thought it should be when we were just making the list earlier, when we were using the common difference. So why is this useful? Well, what if they asked us to find an A number that was way far down the list? Like for instance, find A 100. What is the 100th number in the list? What are our options to find that? Well, the first option would be to make the list going up to 100 numbers. But that's going to take a long time. That's going to take a lot of paper. And the more work we do on paper, the bigger the problem is, the more chances for us to make a little mistake and get a wrong answer. So that's why we want to use our formula. So we go back to the generic formula. I'm going to write it out blank again. Remember, the first term doesn't change. The common difference doesn't change. So that's still going to be 10 and 2. But we're looking for a 100 in this question. So I'm going to say a sub 100, 10 plus 2, it's 100 minus 1 in those parentheses. So just like we've been doing, we subtract, we multiply by the common difference, and then we add it to the 10. One step at a time. Don't go too fast. Don't do too much in your head. 100 minus 1 is 99. Okay, here comes the calculator, so I don't want to make a mistake. 2 times 99, 198. And 10 plus that, 208. So that means the 100th number in the list is 298. I'm going to hold on there for a second. I'm assuming people are taking copies of this. The formula on the top, this is our sequence formula. What we need in order to use it would be the first term, that's a sub 1, and we need the common difference. So if we don't have those, we can't really use our formula. We need to have those two like ingredients for this to work. All right, it's already 11:35. So let's keep moving. I'm going to move back. Okay. So I want you to practice this with me now. Use the given sequence below to do these 3 things. Find the common difference. So we need to find D. Write the formula. So I want to write it out as AN is equal to what plus what times n minus 1. We got to fill in those 2 blanks. And then third, find A27, which means we'll plug in 27 to the formula from part 2. So let's do this in steps together. Question 1. Examine the sequence I gave you below and tell me in the chat if you can find the common difference. What is D for this problem? Or from the sequence? Okay, I see one response so far. I'm going to keep waiting before I look. I want to give you guys a chance to find it. What's D? We got to find that. I see 3 responses. Thank you. Keep going. I want to hear from all of you. Remember, the common difference is what's the pattern. So what are we adding or subtracting to move to the next number in the list? Okay, cool. I see 4 of you. I don't want to look yet. I want to give you guys a chance to type. If you've found it already, I want you to try writing the formula. A sub n equals something plus something equals n minus 1. I see 5 of you have answered. Good. Thank you. Nice job, Brooke. Tatiana, Savannah, Anaya, good. Benningham, good. And you know what? Real quick, I'm sorry I have to go backwards. I want to pause real quick. And would anyone be willing to share with your mic on and tell us how you found D? Would anyone be willing to tell the group how you found D, the common difference? How did you find that plus 5? How do we know?
So I found it by making sure that each number, so 3 to 8 and 8 to 13 and 13 to 18 and 18 to 23 and so on and so forth, I did it by checking to make sure each number was plus 7 or 5, sorry.
Okay. Plus 5. And how, so you checked it by like, you found the 5 and
Adding
then you added it, right? Like 3 plus
Yeah.
5. Levi, I'm going to keep you with me since you answered, if you don't mind. How did you get the 5 in the first place? How did you know that this wasn't plus 10, plus 10, plus 10? I don't mean to pick on you. I am curious because a lot of people answered plus 5, and that means that you found it pretty fast and instinctively that this is a space, right, of 5, and then again of 5. How are we finding that?
Sorry, Josiah, my speaker cut out. I couldn't hear you for a minute.
Oh, my bad.
But just for me, I simply did it by adding from 3 to 8 and then 8 to 13 to make sure that each number was plus 5 and none of the numbers adding up to each number changed.
Very good. Thank you, Levi, for sharing. I really appreciate that. Good job. That's what Levi's describing is, I probably couldn't say it any better myself. Sounds like he's adding numbers up to get from 3 to the next one. Like, what is that space? So you can add up 3 plus, 1, 3 plus 2, 3 plus 3 until you get to 8. Another way to think about it, which I think some of you are probably doing this, maybe, is you're doing subtraction in your head without even thinking about it. 8 minus 3, what is that space? It's 5. 13 minus 8, what is that space? It's 5. That's another way to think about it. It doesn't. We're not going down 5, right? We're not minusing 5. But if you minus any term minus the one before it, you get the common difference. So I'm willing to bet that people are doing it both ways because I don't think about it as subtraction either. But that's what we're finding, and that's why, in the brilliance of all the math minds who've come up with this stuff for us, that's why they call it the common difference, because technically it's a subtraction between like any term and the one before it. And that's what we're doing when you do what Levi described, which is like adding up the numbers in between. You're finding the space in between the numbers. I'm talking too much. Thank you guys for answering that in the chat and verbally. So we found common difference. It's plus 5 this time. Now we need to write the formula. So D is 5. Let me add that up here. Where does that go in our formula? D is the number being multiplied to the parentheses. So I'm going to put that here. What goes in this first blank? Can anyone tell me from the notes, or did you remember? What goes in the first blank here for our formula?
A1.
Oh, you cut off a little. One more time, please.
A1.
A1. Yes, absolutely. A1 stands for the first term. So we can put A1 there. Let's fill that in because we'll need that number as well. So what number should we use this time? Do you mind telling us?
What was the question?
What is A1? My bad.
Oh.
Yeah, thank you, Anaya. Appreciate that. So here's our formula. I'll put that in a box. This is the formula for this particular sequence. A sub n, that's basically the output, is equal to 3 plus 5 times n minus 1. Oh, something in the chat. Beniam, thank you. Yes, correct, sir. Now, Maybe someone's already done this. Maybe you haven't tried it yet, but let's use the formula that we just made to find a sub 27, the 27th number in the list. I'm going to write out the formula again here. And this is what you can use as well. This time though, we don't write it as n, we write it as 27. We're plugging in a 27. Please try using this formula. And if you get an answer for a sub 27, type it in the chat for me. It's okay if you don't get it right this first time. It's okay if you don't want to share it with the whole group. Type it just to me. Please just take a risk and try it out on your own. 27 minus 1, and then multiply that to 5, add it to 3. Follow this filled in formula here. Try this. Let me know what you get. I see one answer. I want to hear from more of you. I want to hear from everybody. What do we get for the 27th number in the list? Cool. 3 of you. Keep going. I appreciate you 3 who have answered. I want to hear from all of you. I want to hear from Philmon and Baraket and Anthony and Xavier and Tatiana and Savannah and Anaya. I know we're on Zoom, but we are not alone, folks.
What?
Anthony, if you can, I want you to try finding A27. Use the formula that we made. You don't have to answer in front of the whole group, but just text me or chat me your answer, okay?
Okay.
Okay. Thank you, sir. You can do it in a step-by-step way. We're always going to be doing the n number, that's 27 this time, minus 1. So that's 26. Not too bad. 26 will be multiplied to 5. I've got to do a calculator for that one because, it's a lot of multiplying in the head. And I can't remember all those. So 26 times 5, 130. That's what I got. And then last step is add it to the first term. Add it to 3 in this case. So that should be 133. Now, I'm not sure. I might have made a mistake. I want to check my work against what you guys did. Oops. There we go. Let me double check. We were trying to find 27. 27 minus 1. 26. Let me double check. 26 times 5. Remember, always do the n minus 1 first. So it's basically, if you're trying to find the 27th term, that's always going to go down to 26. We're always subtracting 1. Then that number, 26, gets multiplied to the 5, the common difference, right here. And then that became a 130, and we add it to 3, the first term. Thank you to everyone who wrote me in the chat. I appreciate you trying it. Okay, let's see. Let's do another one. Okay, here's the first one where the sequence is going down. So here's a new example. Use the given sequence to find the common difference, write the formula, and then find A27 again. So we got to find D. We want to write our formula. And then we want to find A27 again. All right, thank you in the chat. Minus 3. Good job, Savannah, Beniam. Good job. Thank you, guys. D this time is down 3. Now, this is the first one I've given you where it's a negative number. If we're going down same common difference, down, 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 then we're going to show that with a negative D number. So instead of, in our formula, instead of plus 3, this time it's minus 3 because it's going down 3 each time. Don't forget, you need A1. That's the first number in the list. So that's going to be 50 in our formula. And this time it's a minus 3 instead of plus 3. And now to find A27, we're plugging 27 in for n, basically. So we have 50 minus 3, 27 minus 1. Some negative practice here. 27 minus 1, that's still 26, like last time. Okay, 3 times 26, what did we get? 130, let's double check. Oh, that was a different last time. So 3 times 26, I got 78. Double check my work. I might be making a mistake. It's important that we check each other, especially check the teacher, because the teacher is not perfect. So I got 50 minus 78. And now once we do this, we'll have found the 27th number in the list. Negative 28. And it makes sense because it makes sense that we reached a negative number, right? Because if we're going, let's go back to the sequence on the left side. I go down 3, down 3. Eventually, we're going to make it to 0, right? We're going to go underneath 0 to the negatives. So it doesn't mean we did anything wrong. It means when you have a decreasing sequence like this, a going down sequence that's constantly getting lower, it makes sense that eventually we're going to end up in the negative territory. Okay. Now, I wanted to get to one other topic today, but I think it'd be best probably if we just stop here. What we're going to look at tomorrow, actually, we're going to do one more example in just a moment. We're going to do a word problem example. I want to give you a quick preview of what to expect tomorrow. Tomorrow, don't copy down this whole page, but we're going to be adding on the idea of series. Okay, today we were doing sequences, lists of numbers. A series is the sum of the sequence. So a series is like taking the sequence and adding them all up. And that's what we're going to look at tomorrow. So just keep that in mind. We're going to add on series tomorrow, which is adding up all the numbers from the sequence. Let's do an example with a word problem, okay? This is just like we've been doing, but we've got to try to figure out how to turn our word problem into a sequence problem. And then after we do this, I'm going to release you guys, but I want to make sure you have notes on all this. So after we're done here, I want to see your notes for today. So do this with me, please. A theater has 10 seats in the first row, 14 seats in the second row, 18 seats in the third row, and so on. Now, I know it's a little weird because we're talking about a theater. Here's our first row. Let's just make a picture to try to figure this out. Here's our second row, a little bigger. If you've ever been to a movie, well, I guess movies aren't really like this, but concert like arenas and theaters are all built like this. So Golden One Center, they get kind of bigger in the stands the farther away. There's like an extra seat basically on both sides or a couple extra seats. Here's our third row, people sitting in here. Yay! So this says there's 10 in the first, 14 in the second, 18 next. So let's write those out as our sequence. 10, 14, 18, and then ... because we're not being told the next number. They want us to say how many seats are in the 15th row. 15 rows back. So we need to find the common difference. We need to write the formula. And then we need to find A15, A sub 15. What's the common difference this time? What are the rows increasing or decreasing by? Something in the chat. Thank you. Anaya, high five, dude. +4, yes. And we check that out. Confirm it with yourself first. 10 to 14 +4. Good. 14 to 18 also +4. So assuming that this is all increasing the same, which we're going to assume that, our D is 4, +4. Now we just need to put the right parts into our blank formula here, our generic formula. So A sub n, the nth number, is A sub 1. That's the first number in the list, 10. Our common difference is 4. There's our formula. To find A15, we're going to plug in 15 for n. So I'm going to do that in the center here. So the formula is 10 plus 4, but n minus 1 becomes 15 minus 1. Okay, practice this with me. We want to solve this for A sub 15. So in the parentheses, 15 minus 1. Then you do the multiplication. 4 times 14. Do that in your calculators or your phone calculators. That's 56. That's what I got. 10 plus 56, 66. So that means in the 15th row, we should have 66 seats. Okay. I'm going to stop today. We're going to do series tomorrow. But before you go, I want to see everybody's notes, whatever you have. If you aren't able to, I lost somebody. If you aren't able to take notes because you don't have paper, that's okay. But I want to get you paper, okay? I've got plenty of that stuff at the school, paper, pencils, and calculators. So I'm going to pull up my camera here. Savannah, I got you. Thank you. And Levi, I see yours. Anaya, thank you.